Welcome to the exam number 1 review project video for the vehicle miles traveled problem. This project is designed to be very similar to the exam 1 that you'll complete this semester, but it is not the exam project. You will not receive credit if you submit this as the exam. With that in mind, on the CS101 website on the exam number 1 review page, I want to go and download the data files that we'll need for this project. I'm going to right click under vehicle miles traveled problem on where it says data files. I'm going to tell it to save link as. I'm going to save these files to my desktop so that they're easy for me to find. I'm also going to go ahead and open up the instructions PDF so that I know what I need to do. Here on the desktop, I need to extract the zip file before I can use the CSV file that it contains. I'm going to right click on the file and tell it to extract all. The default location is alright, so I'm going to tell it to extract. And you'll be able to see here there's one file inside mileage.csv. With the data files extracted, we're ready to go and create a new workbook in Excel. I'm going to launch Excel and click here to create a new workbook, and then we'll save our file before we proceed any further. I'm going to click the Save button, and I'll enter the file name as specified in the instructions. It's going to be exam review 1 underscore VMTP underscore my last name underscore my first name. And I need to choose where to save this file. I'm going to place it on my desktop so that it's easy to find. So from the drop down here for choosing a location, none of these options is my desktop, so I'm going to go to more locations, and then I'll click browse, and I can go and choose my desktop, and I'll click the save button. Let's get the sheet set up for this project. We need to rename sheet 1 to be mileage, so I'll double click on the sheet 1 tab, and I'm going to type in its new name, and then we need to add an additional sheet to store our analysis questions. So I'll click the little plus button here. That's going to add sheet 2, and I'm going to double click and rename this one as analysis questions. Our next step is going to be to import the data that we downloaded. We're going to do that on the mileage sheet, and the instructions tell us to import starting in cell A4, so I'm going to click there. To do the import, I'll go to the data ribbon, and this is going to be a CSV file that I'm going to be importing from. So under the Get and Transform Data section, I'll click the From Text/CSV option. Now, note that this process will be a little bit different if you're using Excel for Mac as of the recording of this video as compared to what I'm showing with Excel for Windows. But here on my desktop, I'm going to go into the folder where I extracted the zip file, and I have this mileage.csv file that I want to import. I'm going to double click on it, and then I'll get a preview of the data that's in that file. Excel has correctly detected that the first row of data in the file should be the column headings, so I don't need to go into the transform data option and change anything there. I just want to go down at the bottom and tell it to load to rather than just clicking load. I want to bring in this data as a table, and I'm going to place it in an existing worksheet, which is the current one I'm on, starting in cell A4. So after I've chose the existing worksheet option, I'll click OK. And you can see the data that got brought in here, where we have vehicle miles traveled from 1975 to 2020. I don't need to do anything with this queries and connections pane, so I'm just going to close out of it so that it's out of the way. Now let's format the mileage sheet. The first thing that I want to do is make sure that I have a table set up where I imported that data. And in Excel for Windows here, it created a table for me. If I was using a current version of Excel for Mac, as of the recording of this video, I might just have raw cells with text in them, no table formatting. Either way, I do want to go and end up with a table and have that table style not be this green and white striped default. So what I'm going to do is click on cell A4, which is the top left corner of my table, and then I'll hold down the Shift key and click on K50, which is the bottom right corner, and I'm going to go and on the home ribbon say that I want to format as table and choose a different table style. And I'm going to go with this blue heading with the gray striped bars. But you can choose whichever style you like. On the table, I want to turn on the total row option. So when I'm clicked inside of a cell in the table, I'll be able to see the table design ribbon option. And under table style options, I'm going to check the box for total row, which will go and place this new special row at the bottom so that we can calculate some statistics. Now I want to type in some values to finish filling out my sheet. In the top left corner, I'm going to type in vehicle miles traveled in cell A1 to serve as a heading for this sheet. I'll hit enter twice to go down to A3, and I'll type in annual growth rate followed by a colon there. I'm going to tab over twice to go to C3. The next couple columns we're going to enter some percentages. C3 will be 1.0%, D3 will be 1.5%, E3 will be 2.0%, F3 will be 2.5%, and G3 will be 3.0%. I then want to scroll down to the bottom of the table and click in cell A51, which should be the first column of our total row. By default, it just labeled this as total, which is not what I want. We actually want to label this as average. Just as a note, don't go and click one of these other options from the drop-down list. That's going to calculate the statistics, not change the label. With cell A51 selected, I'm just going to actually type in the word average. I'm going to head back up to the top of my document now, and we'll do a little bit of formatting. For cells A1 through K1, where I have this first row going across above the table, I'm going to merge and center that. So on the home ribbon, under the alignment section, I can click the merge and center button. You can see that when I hover over it, it's going to tell me it's merge and center. For A3 through B3, I'm just going to merge this one. I don't want to center it. So back under the alignment section of the home ribbon, there's this little drop down arrow beside the merge and center button. And here I'm just going to tell it to merge across. So it's going to combine the two cells, but it's not going to center them. And the last piece of just visual formatting I want to do right now is for cell A1, I'm going to apply the title cell style to that. So on the home ribbon under styles, I'll go to cell styles and choose title. Now we're ready to set up some calculations in our table. The first thing that we want to do is go down to the total row at the bottom, which is actually going to be our average row here. And for columns B through G, so that's going to be vehicle miles traveled over through the 3.0% rate. We can see this is G51. We're going to average them. So from the little drop down list here, when I click in the cell, I'm going to choose the average option. And I'm doing that for all the cells here. And then for the rest of this table, columns H through K, I don't want to display anything. So where we have this count in the K column, I'm just going to go and change that to be none. Now we want to scroll back up to the top of our table, and in cell C6 we're going to enter a formula from the instructions that will allow us to calculate or project forward here the amount of vehicle miles traveled based on a growth rate and the amount that was in the previous year. You may want to copy and paste this formula. That's what we suggest in the instructions. If you're going to type it in like I am, you want to make sure that you do it exactly as listed. The formula is going to start off with an equal sign, and then we have C5, which will be the cell for the year before the current one. We're going to multiply that by open parentheses, and then we'll have 1 plus C3. C3 is the annual growth rate. We're going to close that set of parentheses, and then we'll do a caret, which will be used for calculating an exponent. And for the exponent part, I'm going to determine that by opening up another set of parentheses, and we'll have A6, which is the current year, minus A5, which is the previous year, so that we can determine how many years are going to be elapsed there. I'm going to go ahead and hit enter now, and you can see it's made this projection for 1976 for the 1% growth rate. The problem is, if we go and copy that formula to the rest of the table, it's going to break. Right now, everything is a relative cell reference, and parts of that formula are designed to refer to specific cells always. Like, we always want to be using this annual growth rate. So if I go and copy that formula, it's not going to work correctly. I need to go and change some of these cell references, and the instructions actually tell me how I need to change them. I'm going to hit the F2 key to go and reopen the formula. C5 should stay a relative reference. It's always going to be just the cell one row up. Where we have the C3 here, we want this to always go and refer to the annual growth rate for our current column. That's the key part here. So we want to make sure that it's always going to refer to row 3's value. But if I go and copy this formula to the right, I do want the column part to be able to change. So I want this to be a row absolute mixed reference, and that means I put the $ just before the row part, which will be the 3 there. A6 and A5, we always want to go and be looking at column A to go and compare year values there. These should be column absolute mixed references, which means we always want column A, but the row numbers should change. So I'm going to put $ before the A part here. Once I've got things edited, I'll hit enter. And then what I'm going to do is autofill this formula over and then down. So I'll just kind of hover over the bottom right corner of the cell and go and drag over, and then I'll go ahead and drag down to the bottom of the table. So you can see right now we have scientific notation, but between 1% growth rate and a 3% growth rate, there's a pretty big difference in the numbers that we're getting. In column H, we're going to calculate the average of the projected values for each of these years. So that's going to be columns C through G. Column B is the actual real number based off of statistics from the Federal Highway Administration. So in H5, since that's the first row, I'm going to start there and write my formula. We'll begin with an equal sign, and I can use the average function to go and calculate an average. For this, I'm just going to drag to select the cells that I want. I'll start with C5, and I'm going to drag over to G5, since that's going to have our 5 different growth rates, and then I'll just close up my parentheses. And I've got that formula there, and I'm just going to press Control-C to copy it to the clipboard, and then I'll just go ahead, click down in the row for 2020 as I'm holding down the Shift key to select everything, and then I can do Control-V to go and paste that. That's just a different way rather than using the autofill handle. Over in column I want to go through and figure out which of these projected values was the largest number. So we'll write another formula here. We'll start off with an equal sign, and as the heading for this column kind of hints, we're going to find the maximum, and the max function will do that for us. So I'll open up the parentheses here for max, and I'm just going to select C5 over through G5. Make sure that you stop in the right column there. And we'll go and close up those parentheses. And we've got that value now. And I'll just use the autofill handle, drag it down. And over in column J, we want to find the lowest number that was projected, the minimum. And this one we'll use the min function for. Again, columns C through G, and go and close our parentheses, and then we'll autofill that one down. In column K, we want to classify the average projected miles into one of three categories. We're going to say we have class A if the projection was more than 3 trillion miles. We'll say that's going to be the value B if it's between 2 and 3 trillion, and the class of C if it was less than 2 trillion. We're going to use a set of nested if statements for that. So in cell K5, I'm going to start off at the top row. We'll do an equal sign, and we'll have an if statement. And our first thing that we're going to do here is check for the A condition. So what I want to do is click on the cell where we have the average, and I want to see if it's greater than 3 trillion. And that's a 3 followed by 12 zeros. If that is true, we'll put a comma, and we're going to say that we want to output the letter A inside of double quotes. If that's false, we'll do a comma for that condition, and we're going to have another if statement. This time we want to check to see if average is between 2 trillion and 3 trillion. We already know that it is not greater than 3 trillion because of our first conditional test. So we're going to see here basically if we are at least 2 trillion, because if it's less than 2 trillion, it's going to be category C. So I want to check to see if average is greater than or equal to 2 trillion. So that's the number 2 followed by 12 zeros. And we'll do a comma then. And here, if that is true, we're going to output the letter B inside of double quotes. And if that's false, that means that we have a value that is less than 2 trillion. We're going to go and output C. And then I'm going to close up my parentheses here, and I've got the value for 1975 saying that that is class C, and our average was less than 2 trillion, so that looks good. Let's go and autofill this down, and you can see here in 1996 we get to where our average is above 2 trillion. That moves into B territory, and in 2015 we're getting above 3 trillion. We're into the A range. So looks like things are working as intended. Let's apply some additional formatting to our tables so that's a little bit easier to understand the values that are here. The scientific notation that we're using just isn't all that user-friendly right now. So what we want to do is go and select the cells where we have numbers. So that's going to be B5 over to column J and down to cell J51. And we're going to format those as number with 0 decimal places, and we're going to use a 1000 separator. With those cells highlighted, I'm going to right click and go to Format Cells, and on the Number tab here, I'm going to choose the Number category. We'll set 0 decimal places and check the box to use a 1000 separator. I'm going to go ahead and click OK. So you can see here lots of numbers. They're very big numbers, but it's a little bit easier now that we have some commas in place to kind of grasp the scale that we're actually looking at. I want to go and auto-fit these columns to make sure that I'm actually going and providing enough space to store everything. So I'll click in column A, and I'm going to drag over to column K, and on the home ribbon I'll go to Format and tell it to auto-fit column width. The last thing that I want to go and do is go and apply some conditional formatting. And I'm going to go and do that to cells B5. So we'll start up here. And we're going to go down to G50. So where we actually have the data for the years, for the original value, and then the different projected rates. And for this here, on the home ribbon, I'm going to go to conditional formatting, and we're going to go and use the green, yellow, red color scale. So we're going to go to color scales, and if I go and hover over things, it's going to tell me this first one is green, yellow, red. So I'll select that. As you can kind of see here, Values that are lower are closer to red. Ones that are higher are closer to green. So we can kind of just scroll through and at a glance now have a rough idea of where these numbers stand. We want to create a line chart to view the vehicle miles traveled. Let's go and select cells A4 through B50. So we have just the year and the vehicle miles traveled. And we want to go to the Insert ribbon, and we'll click on the Recommended Charts button here. I'm going to go head over to the All Charts section, and we'll take a look at the line chart. And you can see that under the 2D style line chart, which is this first section here, it gives us two basic options. The first one has the year plotted as data, which is not anything that really makes a whole lot of sense. What does make sense here is where we go and have the year used as the horizontal axis label going across the bottom there, and we just have one line of data plotted, and that's with the vehicle miles traveled. So this second chart here is the one that we want. It also has a nice benefit that it already has a reasonable chart title. So I'm going to click the OK button, which is going to insert the chart here into our existing sheet. We need to go and move the chart to its own sheet though before we do anything else. So I'm going to right click on the chart and tell it to move chart. I'm going to put on a new sheet that I will call mileage chart. And then I'm going to click OK. We're in pretty good shape with this chart right now. The one big thing that's missing that we need according to the instructions are that we do need to label the vertical and horizontal axes just so that everything is crystal clear what's going on with these numbers. To do that, I'm going to click on the green plus button here, and I'll check the box for axis titles. And on the vertical axis title, let's go and label this as miles traveled. And for the horizontal axis, I'm just going to click in there and tell it that this is the year. One other thing that we want to do with this chart is we're going to add a trend line based on the vehicle miles traveled. For that, I'm going to click to select the vehicle miles traveled line here. And then I can go to the plus sign and choose that I want a trend line. You can see here this little dotted line that's been added. That's my trend line. And it's defaulted to a linear type trend line. What we need to do is figure out which type of trend line is going to be the best fit for us to go and use. And there's a couple things that we want to do here that are going to impact our decision. The first thing is we're going to project this value forward 20 periods. So right now, a period is a year, since we have data for every year. Projecting forward 20 periods is going to take us through the year 2040. The other thing that I'm going to do is I will display the R-squared value on the chart, which is this number here. It's going to be a value between 0 and 1, where numbers that are closer to 1 means that the trend line more closely fits the existing data. So right now it's not too bad. It's a 0.9346. I'm going to go back and select my trend line here, and I'm just going to run through some of these other options to see if any of them seem to be a better fit. They'll have a better R-squared value while also still making sense with what they're projecting. We don't want to end up with projections that are illogical, like we're going to have negative number of miles traveled or things like that. We'll start off with exponential here, and we can see that it's gone with a little bit more of a curve upwards. Its R-squared value is worse. Logarithmic, its R-squared value is way worse. It's 0.8. It's kind of showing that we have this sharp curve up starting in 1975, and then we're kind of flattening out over time. Polynomial is showing a better fit through here. It's 0.97, but it's showing the vehicle miles traveled trending down, which may or may not make sense. And we have power here, which is 0.90. The one thing that's a little tricky with this data set is that there's this pretty sharp drop right at the end in 2020, and that's because of COVID. With the lockdowns, a lot of people weren't traveling that much, so the amount of driving that people did took a nosedive. And that's throwing off, I think, what's happening there with the polynomial projections. It's seeing that downward end, and so it's basically creating a formula that's going to go through and try to match that by curving downwards. With a polynomial type, we can play with the order values a little bit. You can see if we go to a third order instead of a second order, it's a better fit, but it really shows the amount of driving just completely dropping off here. Fourth order kind of shows it leveling and then starting to rebound here. It really kind of depends, I would say basically as a judgment call as to which one's the best fit. I think we have two options that are probably the closest, with being linear, which is showing a pretty much a steady continuous growth, or polynomial, whether we want to do something like a second order, which was the first one we looked at, or a fourth order. I would say a second order probably seems maybe a little more logical, because the fourth order is starting to show a pretty strong upward curve again. But it's sort of a judgment call here as to which one you're going to use. I'm going to go through and use a second order polynomial, because one of the things that if we kind of look here, we can see that the growth is moderating. Kind of once we get sort of after about the 90s or so, the curve that this line follows isn't quite as steep. Now we have a little bit of a drop here because of the Great Recession. Started to pick back up, but things are not really growing nearly at the same pace as we saw before. And if we start thinking, especially maybe in a post-COVID world, people will be working more from home. They won't be commuting as much. Maybe they'll be doing more cases where they're shipping things rather than going and having individual people going out and making lots of trips and things. That could lead to the amount of driving sort of flattening out or maybe even declining a little bit. So I'm going to go with the second order polynomial here, but this is sort of a judgment call as to this one. I think between linear or a polynomial, either of them you could make pretty reasonable cases for. Next, we're asked to make a pivot table. Let's head back to our mileage sheet, and we're supposed to include the pivot table as cells A4 through K50. So I'm just going to type in that cell range here in the cell selector box, and that's going to take care of my header over through the last column and everything except for my total row. With those selected here, I'm going to go to the Insert menu, and I'm going to click the Pivot Table button. And the default settings are fine. I'm just going to click OK. I want to name this sheet Mileage Pivot Table according to the instructions. And I'm going to fill it out as listed here in the instructions. So I want to add the year as a rows field. And I'm going to add the vehicle miles traveled as a values field. We're going to do some formatting here on things. We're going to first of all group the years so that rather than having every single year listed, we're going to group them into groups of 10. I'll click in one of these year cells, and if I go to right click, I can choose the group option. I'm going to start at 1975, so that default, the auto option is fine, and I'm going to group by 10. So I actually don't need to change any settings here. I'm just going to click OK. You can see it's gone and collapsed things down into these 10-year categories. Right now it's going in summing values, which leads to a little bit of weird behavior here, because for this last category there isn't the same number of years going into it. So rather than going and just doing a sum, I'm going to average instead. That'll allow us to more fairly compare the different groupings. For that, I'm going to right click on where we have the vehicle miles traveled sum, and I'm going to go to summarize values by, and I'll tell it that I want to do average. And right now I have scientific notation, which is a little tricky to read. I'm going to go and change this so that it is a number with no decimal places. And I can do that through the pane here for the value field settings, or I can right click and go to number format. And I want to tell it that I want a number with 0 decimal places, and I'm going to use the thousands separator. So you can see here I have my numbers fully expanded out. I've got the commas so I can kind of go and roughly eyeball how large each of these values are. Let's go set up our analysis question sheet, and then we'll do our analysis questions. To set things up here, in cell A1, I'm going to type in question number. B1 is going to be response. I want to bold row 1, so I'll select the entire row here by clicking on the 1 heading, and I'll click the bold button on the home ribbon. I'm going to auto fit the width for column A, so I'll select column A on the home ribbon. I'm going to go to format and tell it to auto fit column width. I'll select column B and go back to format. This time I'm going to tell it I just want to set the column width myself. I'm going to set it to 100. For rows 2 through 5 for your project, where you'll need to answer 4 analysis questions, you'll want to go and select those. I'm going to select 2 through 6 because I'll answer all 5 analysis questions, and I'm going to go and set these to a row height of 110. So with those rows selected on the home ribbon, I'll go back to format, I'll go to row height, I'm going to type in 110 and then click OK. I want to adjust the vertical alignment for columns A and B, so I'll select those, and on the home ribbon I'll click the top align button here under the alignment section, and then the last bit of formatting is going to be just applied to column B. Under the alignment section I'll click the wrap text button, so that if we have long text it'll go and wrap on to a second line rather than spilling out over the right edge of our cell. Let's work through our questions. First question is going to be question A, and this one asks us what trendline type we used and why we chose that type of trendline. My answer here was that I used a polynomial trendline, and I just indicated that it had a good R² value and that I thought it gave a reasonable projection, with the slight decrease in miles driven being realistic based off of recent trends. Question B says that despite some drop-offs in growth of vehicle mileage, there is a steady increase in annual vehicle miles driven over time, at least up until now. What do you think is the main reason behind this? Here, my answer was that I think population growth is the main reason why there's been an increased amount of driving. We have more people, there's more people who need to commute to work, to go shopping, or to have items delivered to them. So all that extra driving equates to more miles traveled. Question C says that the annual growth rate for vehicle miles traveled has slowed in recent years. From 1975 to 1990, the average was 3.25% per year, but from 2004 to 2019, it was only 0.64%. And we're asked what are some potential reasons for this slowed growth. My answer here is that a lot of younger people seem to be less interested in driving than previous generations, so they're not necessarily contributing as many miles traveled. Another thing to keep in mind is during the 2004 to 2019 period, a lot of the time gas was pretty expensive. Regularly saw gas prices over $3 a gallon, sometimes pushing $4 a gallon during that period. So unless you really had to drive, a lot of times people would kind of try to cut back on their driving. So that can be another reason for the reduced growth. Question D says that vehicle mileage experienced declines in 1980 when it dropped by 0.5%, and in 2009 when it dropped by 0.6%. And we're told to provide at least one possible reason for these downturns. In those years, we saw recessions. So if there's a recession, the economy is not doing too well, people are probably not going to do as much discretionary travel. Things like vacations might get cut, and also you might just have fewer people who have to commute to work. So those would be major reasons why you would see a drop in the number of miles traveled. Our final question is E, and it asks, of the different projections, which growth rate best matches the vehicle miles traveled between 1975 and 2020? Do you think the growth rate is still a reasonable fit going forward in the future? And we're supposed to explain our answer. For this question, let's go head over to our mileage sheet. So column B here has the actual miles traveled, and then C through G have our different projections, and you can see the different growth rates that are listed. So one thing that we want to keep in mind here is that we had this dip in 2020. So, that is part of the time period we're looking at, but that might not necessarily be a great indicator for us to use. We might be better off trying to go through and match to some of the previous years, like 2018, 2019. If we go through and look here, looks like a 2% rate got us pretty close to the mark. And it wasn't that bad off even for 2020. A 1.5% rate undershot the mark. 2% is a little bit high, but compared to the other values, it's still pretty close here. So we can say that a 2% rate is the one that best matches. The second part of my answer here is going to be a little bit more of a personal opinion one. Do we think it's still a reasonable fit going forward? I'm going to say that it's probably a little bit high going forward. And that's just based on recent years where we've seen a decline in the growth as people are, younger people aren't driving as much. We have more people who are going to be doing work from home and other things. I think that we're not going to see necessarily that same historical rate in the future. Okay. At this point, we are done with this exam review project. If this was the actual exam, you'd want to go and save your work and submit it through the CS101 website. As a reminder, you will not get credit for the exam if you turn in this project. If you have any questions, contact your section instructor or visit CS101 Open Lab.